Good morning. Thank you all for joining us today for our last installment of the SolidWorks 2017 What's New webinar series. This morning we're going to be looking at 3D Interconnect and the brand new way that we can interact with third-party data from other CAD software in SolidWorks 2017. So 3D Interconnect is part of the collaboration package that we look at with SolidWorks. What 3D Interconnect does is it allows us to pull third-party CAD data from other CAD systems, whether it's from vendors or from legacy data that we might have with our company, into our SolidWorks assemblies, and as well as building new SolidWorks parts based off of those. This is a way to replace the process of going from one third-party system into like a step or a Parasolid file and then into a SolidWorks part without any features. So as we talk about 3D Interconnect, one of the things I wanted to distinguish between it and using the typical translation process of going through an IGES or a step file or a Parasolid file is there's no translation necessary when you're working directly with third-party design data using 3D Interconnect. The benefit of this is there's not going to be a long loading time to convert from the third-party data into a neutral file format and then a second conversion to bring it into SolidWorks. This is going to result in not only easier conversion times because you're not actually having to do a true conversion, but also better performance with opening those final SolidWorks products in general. And using this, you can be able to have access to all the files that you've done in a legacy data system or directly work with suppliers and vendors and their CAD data. With the other collaboration packages of SolidWorks 2017, as we work with whether it's other departments within our company, work with customers, or work with vendors, we always have new tools to be able to manage that data, and 3D Interconnect is just that. It's a brand new tool for us to be able to interact with that data in a whole new way. Other tools like this for maybe for collaboration would be communicating our data out to customers using professional renderings with SolidWorks Visualize and with PhotoV360, or within our own company using data management software like SolidWorks PDM, where we can manage not only, as we talk about legacy data, we can manage not only our SolidWorks data, but we can also manage legacy data and any other file types that we need to with SolidWorks PDM Professional. And so with 3D Interconnect coming alongside these other features, these other solutions, we now have a fuller package to be able to manage that data, whether it was created in SolidWorks or not. And this 3D Interconnect does feature an intelligent knowledge of those third-party tools. When you bring a part in from another CAD system into 3D Interconnect, the faces and edges are preserved, and what that means is that when we create new features based off of those faces or edges, or when we make mates in an assembly or balloons in a drawing, if those files are updated, none of those features would have to be redone. All of those balloons are going to maintain their connections. Any dimensions we have in the drawings are going to work. And we will also highlight how with the way that PTC Creo versions their files and the file extensions, it also recognizes those updates. So these are the file formats that are supported with 3D Interconnect. Right now 3D Interconnect is officially in beta for SolidWorks 2017. To turn it on within your SolidWorks window, you go to the options, and at the bottom of the system options there's an import line. Under file format you'll select Inventor, CATIA, Creo, NX, and Solid Edge, and you can toggle this checkbox to turn on 3D Interconnect. So 3D Interconnect does support PTC Creo files, Inventor, Autodesk Inventor files, Solid Edge, Siemens NX, as well as for SolidWorks Premium customers that will have the ability to use CATIA V5 files with 3D Interconnect. So there's a few different workflows to approach using non-SolidWorks files with your SolidWorks drawings, assemblies, and parts. And we're going to look at a few different approaches, these 3 different approaches for using those legacy data, the vendor data, within the SolidWorks environment. So the first workflow we want to take a look at is inserting the third-party files directly into your SolidWorks assemblies. And this is going to be just like inserting any other SolidWorks component as far as the way you locate the part into the assembly using mates and design around it using a top-down assembly modeling method where you design your parts within the assembly as well as their references to each other. So for this example, we have a battery assembly to insert into this Myomo arm. If you're familiar with the previous What's New webinar series that we've done, we're featuring a company named Myomo that has produced this this augmented bionic arm in order to help patients who have either had a stroke or have a disability and lost some function with one of their arms, that they would be able to control this, and the motors in the arm would enhance their movement, allow them to reuse their arms. The idea behind the name of the company, Myomo, is to restore to patients my own motion. And so with the Myomo control unit that goes on the arm, there we have a little battery pack assembly that we want to take a look at, and suppose it was done in AutoCAD Inventor, either by a vendor or with a legacy third-party tool, and we want to bring that into our assembly here and highlight that workflow process. So I'm just going to switch over to a display state where we can see where we want to house our battery compartment here. And again, just like inserting any parts or sub-assemblies, we use the insert components. And the only difference is now in the open window, the open dialog, for the file types, when you turn that 3D Interconnect on, you have access to several additional file types that you can open through. So we're going to go ahead and select the Inventor assembly. Let me navigate to my vendor files here. And we want to pull in this Myomo battery pack. Now when it pulls in the battery pack, it's not just a visual representation of the battery pack like you would get with maybe an STL type file, a graphics file. We actually do have a model that we can interact with, that we can work with in the assembly environment. So this assembly, once we've pulled it into our SolidWorks assembly, we notice that it has a typical assembly file structure. We can see each of the parts that are contained in that. And the beauty here is we see from these extensions and the 3D Interconnect icon is that these parts and this assembly are pointing back to those original Inventor files. So they're not just bodies in the assembly, they are pointing to those original Inventor files. And we can use them just like we would any other SolidWorks parts to locate them into the assembly. So I'll add a few mates to locate this here. I believe we've got the right plane here from that Inventor assembly. And last but not least, we'll locate the height. And the key here is each of these mates that we're creating, they're all working with faces and edges from both the SolidWorks, the existing SolidWorks parts, as well as that imported assembly. And we'll see as the file updates that there are not going to be any issues with those respective mates updating and the assembly carrying through. Now, one last thing we've got on the battery pack assembly here is we've got this covering, a bracket that will hold the battery pack in place. And once we have it moved and mated into the assembly, you'll notice the toolbox components updating and the holes updating, because these are actually referenced and driven by the size of our Inventor assembly. So inserting it is pretty straightforward, no issues there as far as adding it in just like we would any other assembly. But The key comes in with these type of parts. In the past, if you were working with an IGES or a step file and you wanted to go from one version to another, maybe with this battery pack we need to change the voltage supply from it, or adjust it to larger batteries. And so you can see with this change in the battery pack assembly, we've got 6 batteries instead of the 8 small AA batteries. And the housing has adjusted a little bit larger and more rounded to accommodate those. With a transition like this, working with neutral file formats, parasolids, IGES, and step files, you would have to delete it out and re-add it back into the assembly, add all your mates back in, and if you got anything adjusting, basing off of those would have to be updated as well. What we want to do is we want to, I don't have Inventor, but we will go ahead and just overwrite that battery pack with a new version here. So I'm going to copy these files, and this will be, we're receiving some updated files from the vendor. I'm going to replace those, and back in SolidWorks, once the assembly is rebuilt, we will see the icon beside those 3D Interconnect files change, and it shows that those files need to be updated. So it's watching those files and it has detected that change in there, and all we have to do to allow it to update is right-click on that assembly and choose Update Model. Now that's going to go through and it's not going to delete and recreate the model for us. It's going to go ahead and just totally replace that model with all the mates maintained, with even the visual transparency that I had put on the front cover maintained. And we do see that the references for those toolbox components and for those fasteners and their holes was updated as the assembly updated. So a very straightforward workflow as far as transitioning from one version to another version, whether it's an Inventor file, a CATIA file, or PTC Creo, any of these type of files. It's simply just adding them into the assembly, mating them in place, and then when they need to be updated, you'll see that icon and you can right-click and update the files right there. So very straightforward as far as inserting files into assemblies from other CAD formats. Now with the second workflow I want to take a look at is building a base or derived part based off of an existing part that we have from this one we'll look at is actually from a vendor, and then we can add features to that, much like we would if we started with a step file of something like this pulley. We needed to add our own keyway and our own groove into it, a curved slot into it, and we can do that either way with no problem. But now with 3D Interconnect, as those files get updated, those faces and edge IDs are going to be maintained, and these features will not have to be recreated. So the only difference in this process, instead of importing it, inserting it into our assembly, I'm going to go ahead and just directly open. So File, Open within SolidWorks here. I'm going to go ahead and directly open this primary output pulley .prt, and so this is a Creo file here, and the .1 on the end is how Creo signifies its version 1 of the file, and we're going to come back and take a look at that and the implications that has with 3D Interconnect. But as we open the file, we will see if you've done step file translations or parasolid translations, you know they can sometimes be time consuming. When we're opening these files, you're not going to see anything like that type of translation timing, because it's not actually doing a translation, it's directly opening those files. What we want to do here with this base part, you can see at the top of my screen that it does indicate we're working on a SolidWorks part now with SolidWorks reference planes, the origin located. We have all the SolidWorks features, and then just like you would with a derived part in SolidWorks, this part is based off of an external part file, and so we'll see the reference, the external reference arrow on the side, and the 3D Interconnect icon beside the item there. What we want to do on this one is, once we get these pulleys in, we need to add a custom keyway in, so I'm just going to use my design library here. And the key to notice with this, using the design library, is that we're locating faces and edges. And this is something throughout SolidWorks 2017, not just 3D Interconnect, but the improved process for working with face and edge IDs, even with just regular SolidWorks parts, has improved drastically to where now even with SolidWorks parts, when you do a convert to bodies function, or when you save a assembly out as a multi-body part, those face and edge IDs are going to be preserved. So if you're maybe simplifying your master level assembly with a multi-body part that won't take up as much memory when you run that master level assembly, you won't have to worry about losing those mates, losing those dimensions on the drawings or the balloons with that type of transition. But with 3D Interconnect here, we went ahead and created our derived part and added a couple features ourselves, again using those faces and edges with some design library features. What I want to do is go ahead and drag this into our master assembly, and we'll go ahead and save that as a SolidWorks part. And once we've got that in our master assembly, just like we did with the other part, we're going to go ahead and locate it using the typical mates that we're used to working with in SolidWorks. And one of the things you're going to notice after we have it mated in place is, oops, our pulley is not large enough. The outer rim maybe needs to be resized so we can move that slot outwards. So this is not going to work for us. We're going to need to get back with the vendor and touch base with them, let them know our design requirements, where we're going to need to be able to add that slot in at, maybe lightweight the component a little bit, and they're going to send us a version 2 file. So this file is going to come in from them as a new Creo file with .prt.2 as the extension. So just like we did with the inventor file, I've got an alternate version here that we're going to just add in right beside the original file. And when we get into SolidWorks and we look at this output pulley, we will notice that icon has updated to remind us that that part needs to be updated. Just like we did in the assembly level, we'll right click and update the model, and it will reread that new model, that .2 extension. So 3D Interconnect seamlessly handles that .1, .2 type versioning system that Creo uses. And if we take a close look here, rolling back to just the derived part, they've added some holes in for us and widened that inner diameter where that groove is. And both of our features, the QA and the curved slot, were maintained. So back in our assembly, we'll see that this new design is going to work for us. That slot fits right in with our hard stop, and there should be no issues working with those type of files as derived parts, as base parts in SolidWorks. And then the last workflow we want to take a look at working with 3D Interconnect is creating a part, maybe bringing in an assembly and breaking the link to that assembly from the original part. This would be, for instance, if we wanted to maybe replace a part that was originally designed in a third-party solution. If we wanted to replace that with a part that we were going to manufacture, that we were going to source out separately and replace it into the assembly. So we'll look at using feature recognition and on that type of part, as well as how those face and edge IDs come in as we break the link. So we want to insert an assembly here that is actually going to be from one that was created in Solid Edge. And this drive motor is going to go on the front part of this housing here. We'll place it over to the side and switch to a better angle, a better view where we can see that plate that it's going to mount to there. So in locating this assembly, again, that right now it is currently a just using that 3D Interconnect. And another thing, if you're not familiar with 2016, SolidWorks 2017, the new breadcrumbs feature, I can quickly access that mate to flip the alignment there. Hope y'all are finding great usefulness in those tools. And I do want to locate the motor concentric on this side here. What we're going to notice right off the bat is that this hole on the plate does not line up with the hole that we needed to line up to in the assembly. And so what we would do in this case is simply replace this plate with a plate of our own design. So we'll go ahead and check out the assembly here in the feature tree. We want to break the link from this assembly that's going to the original solid edge assembly. Right click on it, and where we would typically see that update model, we also have the break link tool. And so we'll break the link to the assembly. It tells us this cannot be undone. We're going to break the link to the original CAD model, so that's good. We'll confirm that. What that does is turns that assembly into a virtual part within our master assembly. Now we can open that virtual part. You could save it as an external file if you needed to. For our case, we don't really need to make any modifications to the other components of the motor, just that one adapter plate. So we'll go ahead and break the link for that adapter plate as well, so that it's not pointing to that part anymore. So now we have a new virtual assembly that's pointing to a SolidWorks part that we're about to make some modifications to, and those two original solid edge parts. So let's go ahead and open the adapter plate that we're going to base our model off of. And you notice now that we've broken the link here that it shows as imported data now. It no longer refers out like the other two do, where they refer out to the derived part with a 3D interconnect icon. After we've broken the link, now it just shows as a simple imported body. All this without a long translation cycle going through a Parasolid file into SolidWorks, an export and import process. Now, just like with any other translated body, we can use FeatureWorks design recognition on it. I'm going to edit this whole feature. Now, it's just a body, but when I click Edit Feature, it will use FeatureWorks on it to recognize that as a clearance hole, both a profile sketch. Of course, it's a typical hole wizard feature that we can make adjustments to. But I want to go back into the main assembly and make our adjustments from there. So we'll find the sketch that controls the location of that hole, and when we're editing it, we can put a relation between the point for the location and that external hole on the other part in the assembly. So now we've not only broken the link from the assembly to our master assembly. Of course, we could always make that, save that external if we wanted to use that in other assemblies. But we've also created this SolidWorks part based off of the original one with a hole in the correct location. So working with 3D Interconnect in SolidWorks 2017 makes the translation process obsolete, going from a third-party data into a neutral file format. Now, when you download those files that are created in Inventor or CATIA, Pro-E, you download those files from your vendor's websites. You don't have to translate them. When you're working with and converting from one 3D modeling system to another, or maybe another department within your company, still uses a legacy design system, you don't have to worry about redesigning that in two different CAD systems, but we can again leverage that data, reuse that data without having to translate through that. So that is one of the few innovations, one of the great innovations with SolidWorks 2017, the theme being the power you need to drive innovation. And I think SolidWorks has set a great example of innovation here with this new feature to be able to directly work with 3D CAD formats.